Hi, I'm Tim Spann. I'm a principal developer advocate for real-time streaming, lots of different technologies. Uh, as mentioned, my talk is about working with generative AI and streaming pipelines. We'll do a little intro, do some overview, go into a little bit of some Gen AI architecture, look at some streaming projects, cover some demo use cases, go over some resources, and provide uh, time for people to do question and answers. And if there's not, I give you some time back here. I've been doing streaming and AI and a number of things in uh, New York area for over 10 years at a number of different organizations, covering things like NiFi, Kafka, Flink, Pulsar, different vector databases, AI, ML, different things there. I have an interest in IoT. So if people have some questions on how we can connect this to IoT, I've been doing some work there. I'll show you some resources. Every week I have a newsletter that comes out. You can subscribe or not. It's available in GitHub and a number of other places. You could just read it whenever you want. Covers different open source tools, things that are out, cool new apps, new libraries, new models, videos, different things like that. So let's get to the start. Now, for generative AI, a lot of what you're going to work with is unstructured data. Now, this is not one size fits all. There is a ton of different types of unstructured data. And it starts at, documents, images, video, audio. For most people, this is PDFs and images, maybe Slack chat, Discord, things like that. So what we do is we take this, diverse set of data, apply some different deep learning models, and there are a lot of different models for this. And we give you a list of some of the most common ones, but there's a dozen really good ones that work really well, and there's hundreds of other options and variations. But there's some common ones we use. And this takes this unstructured data, converts it into vectors, high dimension, often sets of arrays that we store in a database, such as Milvus, that makes available for search, uh, which is very helpful. And as you'll see, unstructured data is everywhere, doesn't have a data model, and most of this data just sits somewhere. I mean, maybe people read it, but it's not analyzed, queried in the same way that we work with data that you might have in Postgres, structured, semi-structured data like Parquet, database tables, JSON, even XML. This tends to be text. Again, could be just PDFs, medium, whatever documents you have, images, video, audio, tons of things out there sitting there. And we need to be able to search it. We search it by doing similarities. So now that we have the vectors stored, we have to find something. And by calculating different mathematical items on the data, we can find how similar things are. One such one is inner product, not going back to college math here, but to give you an idea, this is how this works. This is why this is so fast. It is just math on numbers. We get our data in, it's embedded, it's stored in there. When someone wants to do a query, what's cool is we could use those same embedding models to take an image and use it to query against what we have stored. And with the new multimodal models, I could use an image to search text I can use text to search image. And for certain types of models, I can combine text and images together to do my search, which is pretty awesome. And we do an approximate nearest neighbor. Now that's something to remember. For almost all type of indexing in a vector database, we are doing a search against as close as we can get. We're not getting an exact match. This is different from what you're used to for Postgres, MySQL, traditional database, even NoSQL database, where you're doing, word equals cat, and I'm just going to get things that have an exact match on cat. We're going to get things that are, near that, but that gives us the ability to get things that are similar in more ways than just an exact match on keywords. Being able to have a similarity search around concepts and phrases and ideas makes this really powerful. And again, lets you search on these, unusual sources of data, which can be really cool. That doesn't mean we get rid of structured data. This means now we have a ton of sources of data that we need to ingest, enrich, transform, store, search, and use for applications and ton of different use cases and database searches all over the world. Again, we mentioned vector search. We bring in some numbers. Fortunately, you don't have to type in a giant array of numbers, especially when they're floating point. You put in your phrase, it gets converted into a number and gets searched again for you. You don't have to do that, which is pretty cool. So we're going to build some streaming pipelines, take streaming events, prompts, do the calls, process the results, get them back to people, and I'll show you different ways to do this. There are a number of different architectures out there. And again, it depends on, are you doing structured data, unstructured data, semi-structured data like JSON and XML, a combination of those, probably going to be a combination. Your data sources could be on-premise or obviously in different cloud places. And, one of the tools I'll show you today is Apache NiFi. Now, Apache NiFi is not for every use case, but it works pretty well and does a lot of what you can access. And if it doesn't, it'll let you call Python. And as we know with Python, there's connectors for everything. Now, this doesn't mean you have to get rid of your existing Python pipelines, especially the ones that are using, say, Ray or Spark. Things like IBM Data Prep Kit can do some good things as well. But for the use case when you don't know where the data is, it's highly changing. NiFi works very well, supported by a couple of enterprise companies out there, makes for a good thing. Once we've ingested it, very often we want to take data, put it into something like Kafka so we can distribute it, maybe have it go into Flink so it can be real-time queries on it, and then have it stored in a lakehouse, on top of things like Iceberg, or just in our standard S3, Azure, wherever you're storing whatever cloud you're in, Google Cloud. And then enriching it, it really depends where it's coming from. There's a lot of different ways to get data into your system. And these could be sitting in things like traditional databases, like we mentioned, Oracle, Postgres, DB2, or NoSQL stores like Mongo. Fortunately, there's connectors for doing this for NiFi, for Kafka, for Flink. And we could do those through Debugging for CDC. For things like vector databases, NiFi, Kafka, Flink, Python can access those directly. We can even run a lot of this on edge devices, whether that's an NVIDIA, that's one of the more powerful new Raspberry Pis, which I'm doing some work on the new Raspberry Pi AI kit, which has a little more power there. And then we can get this into whatever system needs it downstream with enrichment. Now we could also funnel this into models. Now we can funnel this into simpler models, some of these small language models, which are gaining strength, like some of the ones from Big Science. Or you could do standard things like sentiment analysis, pretty easy. Now, when you're making a real-time pipeline, there is a lot of things to take into account that we have to think about. Now, first off, you have getting the context to build up your calls to your language model. Now, this external context ingest is where the power of something like NiFi comes in, or one of the other open source tools that's similar out there. Ingest, route it, clean it, enrich it, transform it, parse it, chunk it, vectorize, the data, whatever style it is, wherever it's coming from. This can be pretty difficult when you're handwriting this in Python. Now, depends on how frequently things change, how many steps there are, whether this is super complex or not. Now, if you've written it in Python already, say with something like LangChain or IBM Data Prep Kit, you could take that and add that to part of your real-time pipeline and either have it send the results to something like Kafka or a link to the results, if it's stored in S3, the results that you've cleaned up, or you could have NiFi orchestrate this and get that into the pipeline. So run it, get the results, keep going. Building up the prompt. Now, not just, building up this context that you may need for the prompt. This is the original build that context, store it in a vector database perhaps, or wherever it needs to be stored. The prompt engineering is, I'm going to query a large language model right now. So that is something that it needs to happen immediately. So we're going to take whatever your initial prompt is, which could just be a query, or if you want to limit people, you could have a drop down, whatever your UI is. I tend to use something like Slack or Discord, but we could do Gradio, we could do Streamlit, have an app that gets it started with whatever basic prompt, and then do a little quick analysis on that so we know, okay, what do you really need? Is it just grab it from a vector database like Milvus, get those results, format them correctly, perhaps from a template or something else that makes that a little easier? Get that going and get that crafted to the best prompt. What's nice is to keep that isolated, as different models, different ways to call the model may change how you're crafting that prompt. Am I calling a llama? Am I calling OpenAI? Am I calling it via an SDK like LangChain? Or am I calling it, from OpenAI's REST point or their SDK or a library or a helper? Lots of discussions there. Then obviously we built that context. We got to get back and that'll be added to the prompt. And we need to communicate with those applications we mentioned. And some of those can be disconnected. That is something to think about. If I'm dealing with a lot of clients, I may want to have that distributed and having a message bus in the middle like Kafka or Pulsar to be able to, keep me from connecting those directly in case I need to swap out who's processing a particular prompt. Maybe it's something I have cached and I can retrieve immediately from a vector database or from somewhere else. So I don't have to run a new call to language model when you're thinking of maximizing cost, maximizing performance. If it's a common question, maybe I cache it for a certain time locally, maybe even in memory or wherever it's going to be. and then give that back to whoever called it immediately. And, store information on that call so I know, hey, 10 million people are asking the same question. Maybe we should do more research on this. Maybe there should be a human in the loop to enhance it. Maybe we need to improve our documentation if it's a question about, hey, how do I do this thing? Maybe we should add more videos. Maybe we should talk to the dev rel and say, hey, everyone's asking for this. Let's build a new thing there. Things to think about. Now, when I mentioned Apache NiFi, it has just reached the official 2.0 release. This has been something that's been in the process for, seems like a very long time, but it was neat to be. This is a rewrite with a new Python engine, support for a much newer version of Java, which is faster, has a lot more features. This is a great update. This is all JSON based, has a rules engine. If this is the NiFi you want to start with, has all the security features you need. And again, most importantly, a performant version of Python in there that lets us write our own components. Now, why this is important is now if I write some really good Python using various libraries out there, I can reuse this in one of the flows in NiFi, and I could still use this in my Jupyter notebook. So I could reuse some important code that might do something really good. Now, I've written one for extracting company names. Why this is important is when I'm doing a chat, I might need that company name because sure, maybe the call is going right to an LLM, or maybe this is an agent that needs to do a lookup. So I want to pull this out. Now, this one does pretty well just doing PyTorch. Maybe I want to call a small language model. Maybe I want to call a large language model, depending on how good this is extracting. That's something you can watch as the data is coming through. Again, every time you call something with NiFi, it has a provenance that stores that for us automatically. So that makes it pretty easy for us to know, how accurate are things coming through? Are we missing things? So with this one, I get those company names because maybe you say, what's the current stock price for Microsoft? Well, I could send that to the LM, and it could give me some good information on Microsoft. But if I want the current stock price at this minute, I should have something that calls that from there. And again, having that as part of an agent flow that pulls this out makes for a good use case. Again, whether you're using NiFi for your agent flow or one of the great libraries out there, depends on what you need to do. But taking out the company names is probably something that's going to happen, whatever you do there. Now, not every source of data is text. Not every prompt is a question. Sometimes it's images. Now, for me, Salesforce has a pretty good image captioning library, and it's hosted on Hugging Face, which means I can call it from sentence transformers or from a REST call, depending on what makes sense. With NiFi, I could do either. I've written a Python processor to make this call so that I can caption images as they come through the system. And this comes in handy for identifying things. For my use case, when I have a meetup or an event, any pictures captured at the event, it'd be nice to caption them automatically so I can upload them to a Slack channel in a group that does captioning. Boom, this automatically captions it for me, uploads it somewhere else. And that somewhere else could be, Minio, S3, or into a Slack or Discord or Blue Sky, wherever it makes sense. Pretty easy to do. And this Python processor is already available. And again, couple lines of code here, pretty easy. Now, going back to old school ResNet 50, we can classify these images as well. So we can put a caption on them, but also identify what's in the picture. You know, okay, there's 20 people attended the meetup in this picture, and, you know, add all those labels, and we get more metadata, and we can use that metadata to store that into a vector database or into some other image storage place, whatever makes sense. This particular library uses transformers from Hugging Face, looks up the Microsoft ResNet 50 from there, uses PyTorch and some data sets to do this. Pretty straightforward code. Again, couldn't be that much more difficult. So sometimes people are going to want to upload images that we don't really want automatically in our system. Fortunately, there's a couple of different models out there that are pretty good at detecting this. This definitely needs to be something people work on, as these detection libraries aren't perfect, but this model is pretty good. Again, another one on Hugging Face transformer, so pretty easy to write this. So I've got this as one of my processors that makes sure whatever image you have does not have things that we do not want on our Slack group, so we can filter those out. Seeing what's going on with people's facial emotions, that could come in handy. For me today, I am coming off of some surgery on my face, so I'm curious what kind of results I'd get on my face, but I don't think I'm going to run that. But this again gives you labels and scores, different model out there, again showing you how easy it is and how important Hugging Face is. If you haven't looked at Hugging Face, you should get an account, look at all the cool models there. It's a great way to interact with open and free models and models with different licensing requirements out there. Another one that came out this one is not perfect. I've been trying to find a really good address to lat long library out there. This one from OpenStreetMaps is pretty good. It also has partially my name in it, so I kind of like that, the Tim part. This one works pretty good. Why I care about this is I was writing an app in a city in America, and I didn't know where I was. And then I thought, if I'm on a Slack channel and I need to know where things are, yeah, I can pay someone's library, but if I could parse out, you know, based on your lat long, which I can either determine or ask you, and then find what's near you. Because once I know where you are, I can find what's near you, do a radius, you know, start getting, you know, things that might be relevant to you. And I'll show you some examples like where's the nearest bus, where's the nearest restaurant, you know, where's the nearest cat cafe. All those things could be really important. So this is an important library to have. I wrap this in a processor, so again, use it easily in NiFi, but I could also obviously use this pretty straightforward in a Jupyter notebook or in Ray or wherever you want to deploy your applications. Again, there's no right or wrong with these things. It depends on how big your use case is, how much data is coming through, where you want to run it. Like I can process this as a standalone Python app that's called from, is a consumer of Kafka, gets a message, does its work, and then pushes something else into Kafka or Pulsar, and then it's just part of a distributed workload that way. Depends on how you need it. Do you need it immediately? Is it part of a distributed stream? There are thoughts when you're doing this. Is this something where someone's typing and waiting immediately? Is this something I can build up in the background as separate agents all running at once? Again, having Kafka as my bridge to execute all the enrichments and lookups that I might need as part of an agent flow together. That's up to what your use case is. I thought this was cute because we have been mentioning Kafka. Obviously, if you haven't worked with streaming, you might just think it's a really good author with a lot of great books, and I visited his library, but it's also a great tool for working with data. I keep mentioning NiFi. What's nice is open source, easy to run. This is pretty much it. You could just run it right from Docker. It does have security, so you need a login. So by default, we put one in there, and it uses SSL. Again, a great way to make sure you don't leave this powerful tool open to the world. And I highly recommend the 2.0 branch, as that gives us that Python. Here is before I start showing you around different parts of the system and we get into questions. This article is interesting as it shows you how to use the AI kit along with a vector database in real-time image detection. And I got another one to do the similar thing, but with pose estimation. And this one is working with street cameras, which we do the detection, grab the images, do some real-time search so we can find out, hey, is it really busy in traffic in this part of town? Should I take a bus or a taxi or a Lyft or Uber? Or should I, just walk? Is it too crowded? Where our different traffic builds up? And I could look at that by detecting what's going on in different street cameras around town. Okay, so let's show you some actual things going on as opposed to just slides. Thank you for sitting through those slides. But I have a Slack group that I use for grabbing data, and we'll just go through an example. So I asked the question, what buses are near Trinity College in Dublin? Because I was in Dublin at the time. And it takes that question, and I'll show you how we process it. These are the results. I put some metadata in there so I know what I'm doing. And the first one is I thought it'd be interesting as one part of this enrichment, convert it to Spanish. Again, if I had a model that was really good in Spanish, I could pass that along. But here and how many tokens it took, how long it took, I used Hugging Face with 5.3, a smaller model, and that gave me some information on bus routes nearby. Again, Mixtral, great European model there. And this gave me some routes there. And then I called a couple other models to see if how much of a difference there was. Like here I had a Llama 3, and it was pretty good. This one was interesting because it started putting in locations. And as well as that, I found a couple other spots. So we'll take a look at how we did that. Same thing I did in Boston. And you can see we can get results back from the regular models, as well as from us parsing the data ourselves and using that geo library we mentioned to get back a bunch of geo information, and then using that to make lookup calls. As you can see here, we did some NLP processing to see what we could get out of there, and we got what we were closest to, and what your time zone was, and just to show you what we can do pretty easily, and then report that back to our Slack group to have an interactive flow. And how that works is pretty straightforward. Now, if we were doing it in Python, there's a library to receive this information. Here in NiFi, we just have to use a pretty straightforward processor. It takes an app token and bot token from Slack. Again, you could do a similar thing from Blue Sky or from any of the other libraries out there, Discord, and get those calls in, process them. What we do is push it to Kafka so that it can be distributed to other consumers of this who might want this message besides this straightforward path we're going through now. So what we do next is we have this message come in, and then I'm doing things like pulling out fields I care about. Now, because with Slack, it's a big JSON file, lots of information there, the text of your chat, what channel you came from, is there any image or anything attached to it? Get all those particular information we need. And then I'm going to route it if it is for the channel where I answer these, because I don't want people asking them in every possible channel, because that might grab regular conversations. I make sure you're not the bot that I have running in there, so I'm not talking to myself, because that's pretty silly. Push it to Kafka. And we mentioned before, what if someone's putting some junk in there? I don't want to do that. So I clean it up and I call Hugging Face to call that NS not safe for work text classifier. And I'm just using that through the REST call, get the results back. And then I'm going to use a SQL query to parse out if something isn't safe. Now I'm saying I set the score at 45%. You can decide if that should be higher or lower based on your tolerance for potential bad stuff, because there are false negatives in here. So you could also add a whitelist or blacklist of things you want or don't want, gray list it, however you want to do that. If it's safe, then we get to the next step, and I can I can give you a message back saying, hey, you can't, whatever you posted there doesn't appear safe. And if you think it is, then, you could talk to a person and we could filter it out. Now, we could also, if you're asking about buses or stocks, I don't want to send this to a language model. Then I'll search my vector database, parse some documents that come back, extract what I need, add this to the prompt, and build that new information. So we've gotten what we need there. And then if it is, still valid, didn't get munged up, I can call a couple of different models. Usually I like to call Mixtral, as that one is pretty high quality. And again, calling it Hugging Face via the REST endpoint. I don't know how we get the questions. So if they're in the meeting chat, let me know. If not, I'll keep going through the code to see where we are. But just let me know in the questions. I don't see any in there yet, but I'll keep a lookout there. So we get the results back. I'm going to grab just the generated text from the REST endpoint, and then get that into Kafka so I can distribute that to whoever needs to consume it. So again, so we have that distributed. And again, we could call some other models, and then I'll send the result back to your Slack group, and then we just publish it to you along with some metadata. I could turn all that metadata off, but that is really nice for debugging and for seeing things like, what was the total time, as you can see all the metadata there. That is, like I said, data for nerds. We could add a flag there to turn that off. Probably should. And again, especially if you're just doing a chat. But for a demo, it's nice to see, all the information behind the scenes, what's going on there. So we have that getting back. And then when we look at our Slack, you can see what we get back there based on what it is. And there, you can see there's other people consuming this. So we have the chat piece that's done this part against a couple of different models. And then we have other pieces that are handling that elsewhere, depending on what the question is, what enrichment do you want, what you're doing, because we also can listen to other events to get things like uploads. And if someone's uploaded an image, I could check what it is. Is it a PDF? Is it an image? What's the next step? And this is just looking at the file type that Slack gives you. And if it is a PDF, I'm going to parse the PDF, do regular things that I need to do before I insert it into my vector database. And if it's not, if it's an image, I get my image in, make sure it's the right type, and then I'm running YOLO on this. Now, this is one I need to write a custom processor for. This is just running command line one. And you can see that in my linked GitHubs, how to run this yourself. There's also linked for how you can convert this and how this works within this Medium document to give you a good background, step by step, how to change all the things that you're working with. The same for this one with Slack, how to connect to Slack, how to parse what's going through, make it pretty easy. And then again, like I said, when we have the information done, we get it into our vector database, and then you can start searching it, log back in. And it's pretty easy to do, whether that's for important things like cat pictures, or this is other information. Very easy to explore your data here and see what's going on with it. Or if it's something really spooky like ghosts, you can find that information and work with it pretty easy. And it's a very easy way to work with your data. But let's get back to the flow here. So we run the YOLO 8 on there. Probably should update that to 11 and should use my Python processor for that, which I'll link it to the Python processors here. That is in the link for our description of the talk. So let's get to sources. There's a lot of examples out here if you're interested in trying different things out. But if we're looking for the Python processors, we could look at the one for ResNet. And probably the most important thing to see here is just the libraries. And you can see that's just sentence transformers from Hugging Face, pretty easy. And we just grab that model, which we could change. We probably shouldn't hard code that. And then we grab our image, get the results, put that in a label, and then we have that available here. We run our blip, get our text out, fetch it, and then publish that to Slack with all the stuff that we've been building up here. So pretty easy to do. We got 5 minutes left. Okay. Let me see if I can grab this time one in here. I don't see any questions yet. So I guess I'll run it out here, and that's fine. So that's how we do it with NiFi. Now, if you wanted to do this with Python, we could do this with a notebook and just pull in these different processors. Again, even easier to use these without NiFi, but then you don't have this chain of running, which is pretty awesome because I don't know if you could see this, but when something runs through here, we get all the metadata available, everything that's happened, every error, all this is live, and we can see what's going on as it happens, and easily add another branch off this to try another model or work with something different, add a step without having to write code everywhere, and then having the ability to see all the data provenance as things run through the system. So I know every step of everything I'm working on very easily without having to write any custom code. So we are almost out of time. I want to thank everyone for coming to the talk and leave the last little bit here for questions. If you have questions after this, I'll be in Pine looking around, or definitely reach out to me on the channels here, whether it's GitHub, Medium, or X or Blue Sky. Let me know. And thanks for attending my talk here. It's been great meeting with you again. I'm hoping next year that I could be on the ground. I would love to be there in person. Hopefully, I will see you there in person next year.